Good morning, one and all. Myself, Dr. S. Kumar, working as an assistant professor in Department of CSE Honors. Today, we will discuss about the substitution and transposition techniques under Session-3. So, aim of this section is to make sure to understand the students of substitution and transposition techniques. This section is designed to understand the differentiate concepts of substitution and transposition techniques and how to apply them onto the plain text. So at the end of the section, the student is able to compare and contrast substitution techniques and applying the substitution transposition techniques on a given plain text. So today's agenda is introduction about the encryption algorithms and what is meant by substitution technique, what is meant by transposition technique. So this section is provide an overview of substitution and transposition techniques and difference between the substitution and transposition techniques and how to apply substitution and transposition techniques on a given plain text. So substitution techniques are replacing the plain text letters with some other letters or numbers or symbols is called substitution techniques. So we are not using the plain text for the creating of the ciphertext. We are using another letters or numbers, symbols in order to convert the plain text into ciphertext. There are two types of substitution techniques: monoalphabetic ciphers, polyalphabetic ciphers. Monoalphabetic means one letter is involved to create the cipher. Polymorphic ciphers means, poly means, it is a Greek word, it means many. Many alphabetics are used to create the ciphers. So coming to the first technique, Caesar cipher, it is a monoalphabetic technique. Each letter in the alphabet is swapped out with the letter key positions. Lower letters are used as the plain text and higher uppercase letters are used as the ciphertext. The encryption algorithm is C equal to P plus K mod 26 and decryption is the key value here we are adding and here we are removing, and mod 26 is used for because we are having 26 letters in the English. For example, if you take the plain text is A and key equal to 3. So in order to create the ciphertext C equal to A is appearing in the alphabets 1 plus 3 mod 26, you will get 4. That means 4 is which letter? D. So this is known as ciphertext. In the reverse side, what will happen now? So message equal to, what is the C value? D. D means 4. The key value is 3. 4 minus 3 mod 26. You will get 1. 1 is assigned with A. So for our convenience, I am taking capital letters for both encryption and decryption data. For in the reality, it will be represented by using small letters, and the reverse side will get using small letter in order to identifying the things, which is the plain text and which one is the ciphertext. Please remember, always plain text in lower cases and ciphertext is upper cases, and key is the number. Okay, so and mod 26, why we are going to use mod 26? Because we are having only 26 English alphabets. So polyalphabetic ciphers. A polyalphabetic cipher is a sort of encryption methods that encrypts plain text by using many substitution alphabets or many encryption rules. Polyalphabetic ciphers add changes in the substitution process, making them more secure against the frequency analysis. Monoalphabetic ciphers, which have a fixed 1-to-1 substitution for each letter. So we are having Playfair, Wegener, Wengum, 1 time padding. So Playfair, we are having constructing a 5 by 5 matrix and fill the matrix with the alphabets, and we are having totally 26. We are having total 26 letters, but the 5 by 5 matrix is able to give 25 letters to fill in the matrix, so that I and J letter will occupy single column. So the matrix will looks like this. A, B, C, D, E, F, G, H. Here we are going to put I and J. So this is the way how we are going to fill. Suppose if we are having the key is suppose hello, boy is the key, B-O-Y, boy is the key. So first key is filled with this one. After that A is there, no A. B is here, so C, D, E, F, G, H and so on. So whenever you are getting this O is already written, we will discard and we are going to move next letter. So in order to convert it into the ciphertext, we are having 4 rules. So the plain text is converted into 2 pairs. The 2 pairs paired things, pair consisting of 2 letters. If the 2 plain text letters are involving the same row, then the letters by the letters will be taken as the ciphertext. And if it is the last letter, and we are going to use the circular manner. If the 2 letters are in the same column, and we will take it the below letters as the output. If the 2 letters are not belongs to the same row and same column, then the intersection of the letters will be taken as the output of that ciphertext. We will give the input 2 letters and we will get the 2 output letters. So next we are having Veneer ciphers. The key length is not equal to the plain text length. Either repeating the key or write the key many times until we will reach the plain text length. The length of the key, the ciphertext is C equal to K multiplied with P and mod 26, and message equal to K inverse into C. So here P is plain text, C is the ciphertext, and M is nothing but plain text. Okay. So for the Veneer cipher, what we are going to do is we are performing the operation, same operation, that is XNOR operation. If you are performing the XNOR 2 times, you will get the same message. So that way, that is the that's why it is the same encryption and decryption is used, the same algorithm, but you will get the different output. The plain letters are XNORed with the key letters and to get the ciphertext. Okay, here Ci is the ith letter of the ciphertext is created by using the plain letter, ith letter and XNOR with key ith letter. So then we will get the ciphertext Ci. The same process will done here. So one time padding. So this one time padding is what we are going to do is we are going to use every time we are going to use a different letter in order to create the ciphertext. the length of the key is same of the length of the plain text, and it doesn't use the same key for next letter. So it will use different letters. So previously, if the key size is less, what we are going to do is we are going to repeating the key, but in this method the key size and plain text size should be the same. Next, transposition technique. So transposition technique is a cryptographical technique that converts the plain text into the ciphertext by performing the permutations on the plain text. That means exchanging the characters from one position to another position. It includes various techniques like railfare technique, simple column technique, double column technique, etc. So railfare technique involves writing the message diagonally across a set of rails or lines. The ciphertext is created by reading the characters of zigzagging pattern among the rails. To decrypt the message, the reverse process is performed. Singular column technique. By using this technique, we are going to write the plain text in the matrix form. So first we are going to take which column, and next which column you have to take. Based on that, we are going to convert it to the ciphertext. In the reverse side, what we are going to do is the ciphertext is written in the row wise, and based on the key of the structure, we will fetch again the plain text. The same thing is done in the two column manner. Then it is the known as double column transposition technique. So in the summary, we seen the basics of some transposition techniques and substitution techniques such as Caesar cipher, monoalphabetic, Wiener's, polyalphabetic ciphers, whereas some computational ciphers such as Playfair cipher and categories of the polymorphic ciphers. So these are all the self-assessment questions, and these are all the terminals questions. What is the difference between the block of the cipher, stream of the cipher, and general approaches of a cipher. List briefly define types of cipher attacks based on your known attacker. For that, I am going to use Williams-Talemstan's textbook, and this is the website. I am going to take some content about the substitution and ciphers. Thank you.